This is the second set of kinetics multiple choice questions from AQA A-level past paper questions. As always, I'm going to recommend that you pause on the question, have a go at it before listening to the solution. So here's the first one. And we've got here a Maxwell-Boltzmann distribution curve provided. Which letter best represents the mean energy of the molecules? Well, we could go straight to the right answer, but let's look at what you are being distracted by here. D, first of all, that's where we would expect to see the activation energy, way over to the right, because only a small number of particles have energy equal to or greater than the activation energy. We've also got B that we can disregard, which is the most probable energy. That goes to the highest point of the curve. That's the modal energy. Now, we have to remember that the mean energy is always to the right of the most probable energy, so that disregards A. And for all of that, we can then justify that the correct answer is C. Next question for you. And this is a relatively straightforward one. What does the area under the curve represent? Well, the total energy of the particles? No. The energy of each particle is determined by where it is on the x-axis. We've also then got number of particles that can react with each other? No. If we do add the activation energy in, only a very small number of particles have collisions that result in a reaction. So certainly the area under the curve doesn't represent that. And that's also disregarding D, the total number of particles that have the activation energy. Again, it's only this small number at the right. That leaves us with B, which is the total number of particles, one of the fundamental principles you have got to remember when learning Maxwell-Boltzmann. Next question. And on this one, which of the following statements is true? Position A represents the mean energy of a molecule in the container. No, it represents the most probable, the modal energy. The mean would be slightly to the right. Addition of a catalyst moves the position of EA, that's activation energy, to the right. No, it would move it to the left, thereby giving more particles energy equal to or greater than the activation energy, hence the rate of reaction goes up. Jumping ahead now to D, the position of the peak of the curve at a higher temperature is further away from both axes. No, at a higher temperature, the peak moves to the right and it moves down. That would mean it's closer to the x-axis. So that leaves us with C. The area under the curve to the right of activation energy represents the number of molecules with enough energy to react. Another fundamental principle you need to remember, but we've also spent some time disregarding the wrong answers and the distractors. Correct answer is C. And then, final question, total area under the distribution curve represents, and we're going to jump straight to this because it's already been covered in this video. It represents the total number of molecules present. That takes us to the end of this video. Thank you for listening and goodbye.